this video, I'll discuss the use of quantifiers and their negations. You'll want to have your notes with you as you watch this video. Recall that the four quantifiers we'll use in this class are all A or B, some A or B, no A or B, some A or not B. Throughout the course of the rest of this video, we'll determine the negations for each of these four quantifiers. To help us consider what the negation of all A or B is, let's look at an example. In our example, we'll have the statement P, all quarks are spreads. A first consideration might be the negation of P could be no quarks are spreads. Recall that a negation really should include four things. If the original statement is true, the negation is false. If the negation is false, the original statement is true. If the original statement is false, the negation is true, and if the negation is true, the original statement should be false. So let's examine each of those in turn. Looking at this first line, if it's true that all quarks are indeed spriggans, well, then it would be false that no quarks are spriggans. That looks reasonable. 2. Here we're saying it's false that no quarks are spriggans. There aren't any quarks that are spriggans. That's false, rather. It's false that there are no quarks that are spriggans. Well, if we consider what would make that false, we should end up seeing no quarks are spriggans. Well, what if there was one quark that was a spriggan, or two quarks, or three quarks? We don't necessarily need all of the quarks to be spriggans. Again, things that would make this false don't necessarily cause this statement to be true. And what that's going to tell us is that this consideration number 1 is not the negation of that original statement. And in general, the negation of the statement all A or B is not no A or B. Let's look at consideration number 2. For consideration number 2, let's try some quarks are spriggans. Going through the possibilities we need to consider. If it's true that all quarks are spriggans, does that necessarily mean it's false that some quarks are spriggans? Well, in fact, if all quarks are spriggans, some quarks are spriggans is indeed true. This does not work. So consideration 2, that some quarks are spriggans, must be incorrect. Moving on to consideration number 3. For consideration number 3, let's try some quarks are not spriggans. Back to the first step here. If it's true that all quarks are spriggans, well, if all the quarks are spriggans, then it's not true that some quarks are not spriggans. Let's try that again. We're saying here this statement should be false. The statement some quarks are not spriggans, well, there are no quarks that are not spriggans because all the quarks are spriggans. So this is correct. Trying number 2. We're working to the assumption that some quarks are not spriggans is false. This is false. If it's not true that some quarks are not spriggans, well, that means all of the quarks are spriggans. That looks good. Coming down here to step 3. If it's false that all quarks are spriggans, well, then there has to be at least one quark that's not a spriggan. This would be true. Assuming that some quarks are not spriggans, if that's true, here the fourth case, well, we can't have all the quarks be spriggans. That looks good. So in fact, our negation of all quarks are spriggans is indeed some quarks are not spriggans. Nothing about this example revolved around quarks or spriggans, really. So we could just as easily replace this with an A and a B, an A and a B. So we'll see in general, the negation of all A or B is some A are not B. And from that example, we see that the negation of all A or B is some A are not B. Noticing that some A or not B is in fact one of the other quantifiers we've used previously, and noting that the negation of a negation is back to the original statement, the negation of some A or not B must be all A or B. Next, let's consider sum A, R, B. And to do that again, we'll look at an example. In our example here, let's consider Q to be some quixels are quaddles. And as a first consideration, let's try out no quixels are quaddles. Alright, so our first case to consider, we're going to say that Q is true, that is, some quixels are indeed quaddles. If some quixels are quaddles, we want to determine whether or not this makes our first consideration false. If some quixels are quaddles, well, it will be false that no quixels are quaddles. That looks good. Next, let's come down here. We're going to say it's false that no quixels are quaddles. What would make that false? Well, if no quixels are quaddles is false, that means there have to be some quixels that are indeed quaddles. Alright? Now coming down here, if it's false that some quixels are quaddles, if it's false that some are, well, that must mean that there's none that are. Looks good for step number 3. Number 4, if we're saying it's true that no quixels are quaddles, well, does that make some quixels or quaddles necessarily false? It surely does. So we're going to see here again, there was nothing special about quixels or quaddles. And that the negation of some A or B should be no A or B. From that last example, we see that the negation of some A or B is no A or B. Noticing that no A or B is indeed one of our other quantifiers, the negation of no A or B must then be some A or B. Have fun with logic.